All right, today's lesson is over two-way tables and probability, and it's quite interesting actually. And so our essential question today is how to construct and interpret a two-way table. Now, a two-way table is just like a Venn diagram, which is what this is down here, and we're going to put a bunch of numbers in it, and it's going to be much easier to comprehend by looking at the table. And we're also going to look at percentages, so this can get quite confusing. So on the first one here, we're going to survey 80 students, and we're going to ask them two questions. Do they play an instrument, and do they speak a foreign language? And then we're going to put them in this table here. And if you look here, the first question we're going to ask is, or the first assumption we're going to make is, on the row it says speak a foreign language, play an instrument, and not play an instrument. So let's look at, first of all, speak a foreign language and play an instrument. Looks like there's 16 students. How about speak a foreign language and do not play an instrument? Looks like there's 30. So that totals up to 46. Remember, this number here must be 80 because we surveyed 80 kids. Then we said, okay, do not speak a foreign language but play an instrument. Looks like there's 25 there. That adds up to 41. And do not speak a language, foreign language, nor play an instrument. Hey, that's 9. So that's 39. Add 25 and 9 is 34, and guess what? It equals 80. And now because of this, we can answer a bunch of questions that are really quick from the table. How many students play an instrument? Well, here's play an instrument, 41. How many students speak a foreign language? 46. How many students play an instrument and speak a foreign language? Play an instrument and speak a foreign language, 16. How many students do not play an instrument and do not speak a foreign language? 9. How many students play an instrument and do not speak a foreign language? 25. So just look at all the data we just gleaned from just filling that table in based on that little chart. And now we can take this a step farther then and find the probability we're going to select these out of those 80 students. So let's go back. How many play an instrument? Well, 41. So 41 out of 80 is the probability, which is about 0.506. How about speak a foreign language? Well, I believe we had 46, did we not? Speak a foreign language? Oh, sorry, 41. I messed this up. Hold on a second. Play an instrument. How many play an instrument? Yeah, 41. How many? Yeah, 46. That was right. So this is 41 out of 80, and this is 46 out of 80. So that's 0.575. How about play an instrument and speak a foreign language? Well, we have it right there. It's 16 out of 80, which is exactly 20%. 9 do not do either one. So that's about 0.1125. And then play an instrument and does not speak a foreign language was 25 out of 80, which again, just pause this and do your own calculations, but that's 0.3125. So finishing up on your front page there, a two-way table, frequency table, displays data collected from one source that belong to two categories. So one category is represented by rows and the other one is represented by columns. So the rows here is the class and the attendance is the columns. Each entry in the table is called a joint frequency. The sums of the rows and columns are called marginal frequencies, which we're going to find right here in example 1. So if you turn the page, let's just talk about this table. We have 106 juniors, okay, so there we go, and 114 seniors respond to a survey. 42 juniors are planning on attending. 77 seniors are planning on attending. Now, this is easy to figure out who's not attending then. We just subtract them. 106 minus 42 and 114 minus 77. You can check my math, but I'm pretty sure that's right. Well, that adds up to 120 and 119 there. And this has to add up to, not 120, sorry, 220. And then these would then also have to add up to 220, and they do. So that's a two-way joint frequency table. So let's look at, and there's the answers, and you can look through this and make sure that you understand where all those numbers came from. But now we're going to do one with a garden. Here's the garden. And we have asked boys and girls. And you can put male and female, whatever you want. I'm going to put male, females. And gardens, yes, we want it. No, we don't. Okay, and then we'll look at the table. Well, they surveyed 96 guys. 61 are in favor. They interviewed 88 girls. 17 were against. And now you just fill in the table. 88 minus 17. 96 minus 61, it's 132, that's 52, 14, that should be 184, and those add up to 184. So again, we can look at this and just come up with all kinds of probabilities from that table. Now, we can also find percentages called marginal joint relative frequency, marginal relative frequency, and the conditional relative frequency. So now we're talking about ratios when you see relative frequency. So let's go back to that first one, which was this one. And we had 106 or 220 total students, and 42 were attending. 64 were not attending. We can find the percentages then that are attending and not attending by simply dividing them by the total. So 42 over 220, 64 over 220, and then I believe there were 72, and what was that other one? 77, and 37. So 77 and 37 out of 220. And then we can find those percentages, which if you type them on your calculator, you will get these. And you can trust me, or you can actually do it. Now the totals should add up to 1. And those do. And those do. So now we have the probability that we're going to get a junior attending, a junior not attending, a senior attending, and a senior not attending. And survey that's not attending, survey that are attending. So we got all kinds of questions we can answer using this relative frequency table. We now have the probabilities of attendance. And there they are. Okay, so for instance, about 29.1% of the students in the survey are juniors and are not attending. 16.8 seniors are not attending. 51.8% of the students surveyed are seniors. So that's how we can read this table. Now, conditional relative frequency are just a little bit different. Now we're actually going to take these percentages and divide them by the percentages. So in other words, 19.1% juniors are attending out of the total number of juniors. So 0.191 divided by 0.482 now is 0.396. So 39.6% of the juniors are attending. So now we're literally looking at the percentages divided by the percentages of students. in their class. And that's 0.604, and that adds up to 1. Now, same way with the seniors, we get 35% out of, I think it's 0.518, and that's about 0.676, and then 0.168 divided by 0.518, and that's about 0.324. Those add up to 1. Now, they do not add up to 1 this direction, and they shouldn't, because those aren't related. The juniors are not related to the seniors in this table. So pretty interesting stuff. So now we have an actual example of conditional probabilities. We have 3 cities in California: Glendale, Santa Monica, and Long Beach. And we're surveying them about a cable provider, TV provider. So on A, what is the probability that a randomly selected customer who is located in Glendale will recommend the provider? Well, we can see that in Glendale, 29% of them said yes. 5% said no. So if we go to Glendale, what would be the probability that they would recommend it? So in Glendale, thumbs up to Glendale, yes, we do want this. It'd be 0.29 over 0.29 plus 0.05, because the total would be 0.34, and that's 0.853. So 85% of Glendale residents would recommend the TV provider that we're talking about. But on B, so now we're not recommending, and we're in Long Beach. Okay, well, that's different. So we're not recommending, and we're in Long Beach. Well, Long Beach, 4.04 says no, but how many are not recommending? Well, we'd have to add all the non-recommendations and then divide them. So 0.04 divided by 0.12 is 33%, 0.333. So you have to think through these. Now, determine whether recommending the provider to a friend and living in Long Beach are independent events. Well, I would say so. They're really, you live in Long Beach, 32% say yes, 4% still say no, so that would be an independent event. Now, there's a mathematical way of doing that. I'm not going to get into that. We don't really care about that anyway for what we're doing. Okay, and then we have a couple more, and I missed that on this slide. So on number 5, what is the probability that a randomly selected customer who is located in Santa Monica will not recommend this to a friend? Well, Santa Monica no's are 0.03, and the total for Santa Monica is 0.30, which is 0.10. And then again, is this independent? Are these independent events? Sure, because everybody's got their own opinion. Now, will they be swayed? Maybe a little bit, but pretty much that's the way it would be. Okay, now the last one is pretty cool. Comparing conditional probabilities. We actually have to look at the totals here and actually calculate the decimals that go along with this, the marginal frequency. So we get the relative frequency, sorry. So you have 50 times you're running these routes total. We ran route A 11 times where we reached our goal and 6 where we did not. So that would be 11 out of 50 and 6 out of 50. And this would be 0.22 and 0.12. So in the route B, it's 11 out of 50. So we all know that's 0.22. But we failed to meet our goal 4 out of 50, which is 0.08. Again, you can check my math. 12 out of 50 on my calculator is 0.24. And 6 out of 50 is still 0.12. And if we add those across, 0.34, 0.30, 0.36, let's see, 68, 0.32, you get 1. And now from this, we can answer the probability questions, which are, what's the probability we reach goal on Route A? If you said 0.22 divided by 0.34, you would be correct, because we reach goal here and we have a total 34% of the time we ran A. So that would be about 60.647, 64% of the time we would make it. How about Route B? 0.22 divided by 0.30, because there's the total there, and that's about 0.733. And finally, Route C is 0.24 divided by the total, 0.36 on C, and that's 2/3. That's 0.667. So it's pretty cool to look at a table and find probabilities without having to really calculate much. We just add and divide. So let's make sure and check them. Yep, that's what we got. So we're good. So if you would go to page 300, this is your assignment. Don't give the sub too much grief. Get busy and make sure you got your notes handy.